Hello students, today we shall learn lesson 13 Pythagoras theorem. Right angled triangle. Now let us see what is a right angled triangle. A triangle with one right angle is called a right angled triangle. That is, if one of the angle is 90 degree, then that triangle is a right angled triangle. And the side opposite to the right angle is called the hypotenuse. Just look at the triangle over here. Triangle ABC is a right angled triangle. Here angle B is 90 degree and the side opposite to angle B is segment AC. So segment AC is the hypotenuse of the triangle ABC. Pythagoras theorem. Pythagoras was a great Greek mathematician of the 6th century BCE. He was the first to prove the theorem based on right angled triangle and hence the theorem is named after him. This theorem of Pythagoras states that in a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Here in this triangle ABC, AC is the hypotenuse. So AC square equals to the sum of the other two sides will be AB square plus BC square. That is hypotenuse square is equal to base square plus height square. Now let us solve an example based on Pythagoras theorem. Given two sides of a right angle triangle, you can find the third side using Pythagoras theorem. For example, in triangle ABC, angle C equals to 90 degree, length AC equals to 5 centimeter and length BC equals to 12 centimeter. You have to find the length of segment AB, that is the hypotenuse. So in the solution, first we'll write down what is given. That is, in a right angle triangle ABC, angle C equals to 90 degree and side AB is the hypotenuse. So according to Pythagoras theorem, what does Pythagoras theorem says? Hypotenuse square is equal to sum of the square of the other two sides. That is, AB square equals to length AC square plus length BC square. Now we'll substitute the value. Length AC equals to 5 centimeter and length BC equals to 12 centimeter. So we can write 5 square plus 12 square. And 5 square is 25 and 12 square is 144. So length AB square is equal to 169. That is 25 plus 144. And 169 is the square of 13. So we can write length AB square is equal to 13 square. Now removing squares from both the sides, we'll get length AB equals to 13. Therefore, length of segment AB equals to 13 centimeter. Now let us solve practice set 48. The first sum. In the figure given below, find the value of x. So here we have right angle triangle LMN, where length of LM is 7, length MN equals to 24 and Ln is given as x. We have to find the value of this x. So by Pythagoras theorem, which states that hypotenuse square is equal to sum of the other two sides. So we can write Ln square equals to length Lm square plus length Mn square. Now we'll substitute the values. Ln is x, so we can write x square. Lm is 7, so 7 square, and Mn is 24, so 24 square. So we can write x square is equal to 7 square plus 24 square. 7 square is 49 and 24 square is 576. So we will get x square is equal to 49 plus 576. If you add 49 and 576, it comes to 625. So x square is equal to 625. And 625 is the square of 25. So we can write x square equals to 25 square. If you remove the squares from both the sides, you will get x is equal to 25. Therefore, the value of x is 25. Now look at this sum. Here we have triangle QPR where angle Q is 90 degree. So the hypotenuse will be segment PR, which is given as 41. The other side QP is given as 9. We have to find the length of QR, which is given as x. So by Pythagoras theorem, which states that hypotenuse square is equal to sum of the square of the other two sides. So we can write length PR square equals to length PQ square plus length QR square. Now we will substitute the value. PR is 41, so it will be 41 square equals to QP equals to 9, so 9 square plus QR is x, so x square. So 41 square equals to 9 square plus x square. Now we'll have to take the square of 41. That is 41 into 41, if you multiply, it comes to 1681, which is equals to 9 square, that is 81, plus x square. We'll just rearrange this. So it will be x square plus 81 equals to 1681. So we have to find x square. So x square equals to 1681 minus 81. So if you subtract 81 from this, you will get x square is equal to 1600, which is the square of 40. So we can write x square is equal to 40 square. If you remove the squares from both the sides, you will get x is equal to 40. Therefore, the value of x is 40. Now let us solve the third sum. Here we have triangle EDF where angle D is 90 degree. So the hypotenuse is EF, which is given as 17. The other side DF is given as 8. We have to find ED, which is given as x. So again, by Pythagoras theorem, which states that hypotenuse square is equal to sum of the square of other two sides. So we can write length EF square equals to length DF square plus length ED square. Now let us substitute the value. EF is 17, so 17 square equals to DF is 8, so 8 square plus ED is given as x, so we will write x square. 17 square is 289, so we can write 289 equals to 8 square 64 plus x square. Now let us rearrange it. So x square plus 64 is 289. We have to find the value of x square, so we will write x square equals to 289 minus 64, which comes to 225. So we can write x square equals to 225. And 225 is 15 square. So we can write x square equals to 15 square. Now let us remove the square from both the sides. We will get x is equal to 15. So the value of x is 15. Now let us solve this sum. In the right angle triangle PQR, angle P equals to 90 degree. If length PQ equals to 24 centimeter and length PR equals to 10 centimeter, find length of segment QR. To understand this sum better, first let us draw the triangle PQR, where angle P is 90 degree. So if angle P is 90 degree, that means QR is the hypotenuse. So we are supposed to find the length of QR, which is the hypotenuse. Let us write down the length PQ as 24 centimeter and length PR as 10 centimeter. Now, what is given in the sum? In triangle PQR, angle P is 90 degree, segment QR is the hypotenuse. So by Pythagoras theorem, length QR square equals to length PQ square plus length PR square. Now let us substitute the value. PQ is 24, so we can write PQ square as 24 square and PR is 10, which is equals to 10 square. So length QR square is equal to 24 square plus 10 square. And if you find the square of 24, it comes to 576. So 24 square is 576 and 10 square is 100. So it comes to 576 plus 100, which is 676. So length QR square equals to 676. And 676 is the square of 26. So we can write length QR square equals to 26 square. Now let us remove the square from both the sides. So length QR equals to 26 centimeter. Therefore, the length of segment QR equals to 26 centimeter. Now let us solve the third sum. In the right angle triangle LMN, angle M equals to 90 degree. If length LM equals to 12 centimeter and length LN equals to 20 centimeter, find length of segment MN. Again, we'll first draw the diagram so that it will be helpful for us to solve this sum. So, triangle is LMN where M is given as 90 degree. Hence, our hypotenuse is segment LN and LN is given as 20 centimeter and LM is given as 12 centimeter. We are supposed to find the segment MN. So we'll write down what is given in triangle LMN. Angle M equals to 90 degree. So segment LN is the hypotenuse. Since it's a right angle triangle, again by Pythagoras theorem, length LN square equals to length LM square plus length MN square. Now let us substitute the value. Ln is 20, so 20 square. Lm is 12, so 12 square and length Mn square. So We have to find length mn square. So we'll write length mn square equals to 20 square minus 12 square. 20 square is 400 and 12 square is 144. So we'll write 400 minus 144, which comes to 256. So length mn square equals to 256 and 256 is 16 square. So we can write length mn square equals to 16 square. If you remove the square from both the side, length mn equals to 16 centimeter. Therefore, the length of segment mn equals to 16 centimeter. Now let us solve the fourth sum. The top of a ladder of length 15 meter reaches a window 9 meter above the ground. What is the distance between the base of the wall and that of the ladder? To understand this sum, first let us draw the ladder and the wall. Here BC is the wall, AC is the ladder and C is the window. And given the length of the ladder is 15 meter and the window is 9 meter above the ground. Here A is the foot of the ladder and B is the base of the wall. And we have to find the distance between the base of the wall and that of the ladder. That means we have to find segment AB. So let us solve this sum. Let BC be the wall, AC the ladder and C the window. Given length AC equals to 15 meter, length BC 9 meter and AB we have to find. So let us write length AB equals to x meter. As the arrangement is like a right angle triangle, we'll solve it using Pythagoras theorem. So by Pythagoras theorem, length AC square equals to length AB square plus length BC square. Now let us substitute the value. AC equals to 15, so we'll write 15 square. AB equals to x, so we'll write x square. BC equals to 9, so we'll write 9 square. So 15 square equals to 9 square plus x square. We have to find the square x square. Now 15 square is 225. X square will write as it is. 9 square is 81. So therefore x square equals to 225 minus 81, which comes to 144. And 144 is 12 square. So we'll write x square equals to 12 square. Now let us remove the squares from both the sides. We'll get x is equals to 12 meter. Therefore, the distance between the foot of the ladder and the base of the wall is 12 meter. Pythagorean triplet. If in a triplet of natural numbers, the square of the biggest number is equal to the sum of the squares of the other two numbers, then the three numbers form a Pythagorean triplet. If the lengths of the side of a triangle form such a triplet, then the triangle is a right-angled triangle. Now let us solve an example based on Pythagorean triplet. Do the following numbers form a Pythagorean triplet? 7, 24 and 25. According to Pythagorean triplet, the square of the biggest number should be equal to the sum of the square of the other two numbers. Here the biggest number is 25. So let us check whether the square of 25 is equal to the sum of the square of 7 and 24. So let us take the square of all the three numbers. 7 square is 49, 24 square is 576 and 25 square is 625. And 25 is the biggest number and the square of 25 is 625. So let us check whether the square of the sum of the square of the other two numbers comes to 625. So 7 square 49 and 24 square 576 and 49 plus 576 comes to 625, which is equal to the square of 25. That means 7 square plus 24 square equals to 25 square. Hence 7, 24 and 25 is a Pythagorean triplet. Now let us solve practice set 49. First sum. Find the Pythagorean triplets from among the following set of numbers. Here we have 3, 4 and 5. First let us take the square of all the three numbers. 3 square is 9, 4 square is 16 and 5 square 25. Among the three numbers, 5 is the biggest number and the square of 5 is 25. So let us check whether sum of the square of the other two numbers, that is 3 and 4, whether it comes to 25. 3 square is 9 and 4 square is 16 and 9 plus 16 is 25. which is equal to 5 square. That means 3 square plus 4 square is equal to 5 square. And hence 3, 4 and 5 is a Pythagorean triplet. 2, 4 and 5. Now let us check whether 2, 4 and 5 is a Pythagorean triplet. First let us take the square of all the three numbers. 2 square is 4, 4 square is 16 and 5 square 25. Among the three numbers, 5 is the biggest number and square of 5 is 25. So let us check whether the square of the sum of the square of the other two numbers, that is 2 and 4, whether it comes to 25. So 2 square is 4 and 4 square is 16. 4 plus 16 comes to 20 and which is not equal to 25. That means 2 square plus 4 square is not equal to 5 square. And hence 2, 4 and 5 is not a Pythagorean triplet. 9, 40 and 41. Now let us check whether these three numbers form a Pythagorean triplet. So let us take the square of all the three numbers. 9 square is equal to 81, 40 square is 1600, 41 square is 1681. Among the three numbers, 41 is the biggest number and square of 41 is 1681. Now let us check whether 9 square plus 40 square comes to 1681 or not. 9 square is 81 and 40 square is 1600, and 81 plus 1600 comes to 1681. That means 9 square plus 40 square is equal to 41 square. Hence 9, 40 and 41 is a Pythagorean triplet. 4, 7 and 8. Now let us check whether 4, 7 and 8 is a Pythagorean triplet or not. So let us take the square of all the three numbers. 4 square equals to 16, 7 square equals to 49, 8 square equals to 64. And out of the three number, 8 is the biggest number and square of 8 is 64. So now let us check whether 4 square plus 7 square comes to 64 or not. 4 square is 16 and 7 square is 49. And 16 plus 49 is equal to 65, which is not equal to 64. That means 4 square plus 7 square is not equal to 8 square. So 4, 7 and 8 is not a Pythagorean triplet. The sides of some triangles are given below. Find out which ones are right angled triangle. If the length of the sides of a triangle form a Pythagorean triplet, then the triangle is a right angled triangle. Here we have 8, 15 and 17. Let us check whether these sides form a right angled triangle. Among the three numbers, 17 is the biggest number. Square of 17 is 289. So let us find the square of 8 and 15 and add them. If it comes to 289, then it is a right angle triangle. 8 square is 64 and 15 square is 225. 64 plus 225 is 289, which is equal to 17 square. Therefore, 8 square plus 15 square is equal to 17 square. And hence it is a right angled triangle. 11, 60, 61. Now let us check whether these three sides form a right angled triangle or not. Among the three numbers, 61 is the biggest number and 61 square is 3721. Now let us check whether the sum of the square of 11 and 60 comes to 3721. 11 square is 121 and 60 square is 3600. And 121 plus 3600 is equal to 3721, which is equal to 61 square. So 11 square plus 60 square is equal to 61 square. Therefore, 11, 60, 61, these three sides form a right angled triangle. Now let us check whether 1.5, 1.6 and 1.7 form a right angled triangle or not. Here among the three number, 1.7 is the biggest number and the square of 1.7 is 2.89. Now let us check how do we get this. Just look at the working column. 17 square is 17 into 17, which is equal to 289. So if it is 1.7 square means 1.7 into 1.7. Here the after point there are two numbers. So the answer will be 2.89. After point there will be two numbers. So 2.89. So 1.7 square is 2.89. Now let us check whether the sum of the square of the other two number comes to 2.89 or not. 1.6 square is 2.56 and 1.5 square is 2.25. Let us take the sum of that. 2.25 plus 2.56 is 4.81 and which is not equal to 2.89. Therefore, 1.5 square plus 1.6 square is not equal to 1.7 square. Hence, the side 1.5, 1.6 and 1.7 do not form a right angle triangle. Now let us check whether the sides 40, 20 and 30 form a right angle triangle or not. Here among the three numbers, 40 is the biggest number and square of 40 is 1600. Now let us take the square of the other two numbers. 20 square is 400 and 30 square is 900. And the sum of 400 and 900 is 1300, which is not equal to 1600. That means 20 square plus 30 square is not equal to 40 square. So 40, 20 and 30 do not form a right angle triangle.